Welcome to Anywhere Math. I'm Jeff Jacobson, and today we're going to talk about writing expressions. Let's get started. Alright, if you're like most people, you might think simplifying expressions is no big deal. But when it comes to writing them from a word problem or a phrase, then you start to get a little nervous. So let's break it down. With writing expressions, it's all about finding those key words. So if you look right here, copy this chart down. These are the key words and the corresponding operations that you should be looking for. Okay, keep an eye out for these words. So pause the video, write this down, and these are words you really have to memorize and what they correspond with what operation. Some of them you should already know. Okay, let's get started with example 1. So write the phrase as an expression. We've got some phrases, we're going to turn them into expressions. So again, we're looking for those key words or phrases. So 8 less than 21. Hopefully you recognize less than from that chart. And you remember that less than, we're talking about subtraction. But less than is really an important one to know because the order for these numbers is going to be switched. But here, less than, it's actually not going to be 8 minus 21. It's going to be 21 minus 8. Okay? We're saying 8 less than 21. So we're starting with 21 and subtracting 8 from it. This is my answer. That's my expression. Remember, we're writing expressions. I'm not actually asking you to simplify that. I don't want you to actually do 21 minus 8. We stop right there, and that's your expression. So in the chart, less than and more than, I would put a big star next to those. More than and less than. Put a big star next to those and maybe write, pay attention to the order or something. Okay? Because that's a really common mistake I see a lot of students make is that if they were doing this, they would write 8 minus 21 instead of 21 minus 8. So more than and less than, really pay attention to those orders because it's switched. Okay? Let's do the next one. B, the product of 30 and 9. Okay? Well, let's look for the key word. Here, it's product. I also want to say something about these terms, sum, difference, product, and quotient. They're all related. They're all kind of the same type of term. We know product is talking about multiplication. When you see those words, sum, difference, product, quotient, they come in pairs. Always also look for and. Because that is where the operation goes. So we know product means multiplication and is where we put it. So the product of 30 and 9 means 30 times 9. Okay, and we know when we write it next to the parentheses it means multiplication. You could also write 30, right? You could do that as well. So make another note in that chart. Sum, difference, product, and quotient. Pay attention to the and, right? Look for and. That's where the operation will go, okay? Let's try another example. Okay, example 2. Write the phrase as an expression. So we're doing the same thing from example 1. We're looking for those key words. Let's start with A. 14 more than a number X. Well, hopefully the key phrase that you see here is more than. Okay. And we remember more than means addition. So what are we adding? We've got 14 and we've got a number X, right? Now, we're no longer writing numerical expressions, we're writing algebraic expressions. And if you remember from the video before, it's going to be an algebraic expression because we have an unknown. We've got a variable. this x. So let's write it. We know we're dealing with addition. If you remember from example 1, more than, you got to remember the order is changed. So instead of 14 plus x, it's going to be x plus 14. Let's go to B. The quotient of 3 and a number w. Let's look for that key word. So hopefully you recognize quotient. And if you remember, sum, difference, product, quotient, all 4 of those also look for and. They come in pairs. Quotient and. That and is where the operation goes. Quotient means division. So I'm doing 3 divided by w. So I'm going to write that 3 divided by w, or 3 over w, just like that. Okay? Last one, C. The difference of 2 and 3 times a number. So this one's a little more complicated. Let's look for those key words. Difference, hopefully should stick out. You also look for and. Remember, just like here, quotient and, difference and. And then also you should see times. Okay, times. So, difference means subtraction. Well, what are we subtracting? We're going to subtract 2, and is where that subtraction goes. So, I'm going to start with 2 minus 3 times. Well, times means multiplication. What am I multiplying? Oh, I'm sorry. I should have, let's go with P. I forgot to write my variable there. So 3 times P. And we can write that as 3P. So there's my algebraic expression for this phrase. Okay? Here's some to try on your own. All right, here's our last example. You plant a tree that is 10 inches tall. The height increases by 15 inches each year. So part A, write an expression to represent the height of the tree in T years. All right, so now this is where it really gets a little bit more complicated, but the process is the same. We have a word problem. We're still looking for those key words or phrases. So if you look here, hopefully one word jumps out at you, and that would be, or phrase, increases by. Okay. Well, we know that means addition. Okay. So when we're writing our expression, we got to know that we're going to be using addition. So that helps. We also know that they want us to write an expression to represent the height of the tree in T years. T is going to be our variable. So we're going to have an algebraic expression. Okay. Well, let's think about it. How tall is a tree when we start? Before even 1 year, when we just have the tree, how tall is it? Well, we know it starts out at 10 inches. So I'm going to start with 10. That's where we're starting. It increases by 5 inches each year. Sorry, 15 inches each year. Increases means I'm going to be adding. And if you think about it, if it was 1 year, I would be adding 15 inches. If it was 2 years, I'd be adding 30. 3 years, I'd be adding 45. What am I doing each time, right? Well, each year, 15 inches each year, that means I'm going to be multiplying those. So I'm going to write that as 15 times the number of years. Remember, if it was 1 year, 15 times 1 is 15. So I'm adding 15. If it was 2, 15 times 2 is 30. I'm adding 30. And the variable I'm using is t. Okay? Now, when you have your expression, always just double check. See if it makes sense. Okay? Because if it doesn't, then you might have a problem. Well, let's see. If this expression represents the height of the tree after t years, what if it was 0 years? Well, we would substitute 0 in here, and 15 times 0 is 0, plus 10 is 10. So after 0 years, is the height of this tree 10 inches? Yeah, that's what it started at. After 1 year, 15 times 1 is 15. Add that, it would be 25 inches tall, which makes sense because every year it grows 15 inches. So that is my expression. Okay, I'm happy with that. It's an algebraic expression because it has a variable. Let's look at the next one. B, use this expression to find the height after 9 years. Well, we know t is the variable that represents years, so I'm going to substitute 9 in for t. So it becomes 10 plus 15 times 9. Always use your parentheses when you're substituting. So 10 plus, my order of operations say I got to do this multiplication first. 15 times 9, well, 9 times 10 is 90. 9 times 5 is 45. 90 plus 45 is 135. And if I add those together, I get 145. Remember your units, we're talking about inches. So after 9 years, I would expect the tree to be 145 inches tall. Here's one more to try on your own. As always, thank you so much for watching, and if you like this video, please subscribe.